So, like I said yesterday, that we have different types of variables. We have continuous variable. Uh, we have continuous variable. We have quantitative. Then basically we have qualitative and quantitative. The other qualitative have nominal and ordinal. Then while under quantitative, we have continuous and interval. So today we are going to look at introduction to choosing the right statistic. So when we talk about statistical test, now we must know that for you to be able to do to have a quality outcome, you must be able to choose the right statistical test. Now, statistical tests are actually the different kind of tests that you use to check the kind of relationship that exists between two groups. So, based on that, there are some questions that that you must ask for you to be able to know the kind of statistics that you are to use. And the first question that you will always ask is that, now, what is the outcome or dependent variable are we talking about? So in this case, we're talking about this outcome variable. Is it continuous, or is it qualitative or quantitative? So when you answer that, then the next thing that you need to tell yourself is the outcome variable continuous or binary or categorical? When we say binary, categorical, yes or no, present or absent, and all of that. So the next one is that the unit of observation. Are we talking about the person-to-person, or was this data collected via person-to-person, or it was through a physician or in the clinical center? Now, the next thing is that, are the observations dependent or correlated? Now, when we say dependent, are they dependent on each other? Are they related? Are these observations unrelated? If they are independent, meaning that they are not related. But if they are correlated, meaning that one would affect the other one. So please, after this class, remind me to send the software, the link to the software, so that you guys can download it. So that you can download it. Then I will also you can even install it without me be there. Then if you're having any problem, then you can let me know.
Okay.
So now,
Okay.
yeah. So the next thing is now, like I said yesterday, when you have the population, the next question you will ask yourself is that, is this population, is it a one sample population? Is it a two sample population? Or is a 3 or more sample population? Now, what are we saying in essence? For example, we know that there's already an established reference value, for example, for glucose, for total cholesterol, and all that. Now, you may want to compare the cholesterol mean value of all your patients, let's say all the male patients that come to your hospital, let's say in a week, you compare it to reference uh, your reference value, for example, for cholesterol. Now that is a one sample population, because the only population you are looking at is the cholesterol level of all the male subjects. Now, when we say two population, now let's assume now you try to compare the cholesterol level of the male patient uh, and the female patient, or the cholesterol level collected in 2022 of male patients and the cholesterol level collected in 2021. That is 2022 against 2021. You know, uh, they are still two groups, but we are looking at the level
Yes.
at 2020, 2020 against 2021. So 2020 is a group, while 2021 is another group. Now, if you now have three group or more, let's say you are trying to look at the cholesterol level of the different of the males in the six geopolitical zone. No, now we have six group here. We have the
Okay.
northwest, we have the south-south, we have the southeast, we have the southwest, we have the north-central, we have the northwest, then we have the southwest. So yes, all of them are still cholesterol, but you are comparing six different cholesterol of six different groups. I don't know if you get that. So it means that
Yes.
when you are um, the type of statistic you are going to choose will depend on the population you are looking at. That's the first point of call. Now, the next thing that you will ask yourself is this sample drawn from a normal distribution? That is the next thing we are going to look at after this. Now, we're going to look at to determine normality, although not today, probably tomorrow. So it means that on Friday is when we are going to be looking at the software itself. Friday, Saturday, and Sunday, and most likely maybe we'll finish up by next week. So, so that's that. Now the next question is that if these sample are drawn from normal normally distributed group, you will be looking at one sample t-test. So one of the tests you usually run in statistics is one sample t-test. Now, one sample t-test in the sense that you already have an established value, which is like your reference value that you are using to compare. So it's only one group you are comparing to the established population. Now, if it's a normal distributed sample, then you'll be using one sample t-test. But if it's not, then you'll be using Wisconsin rank sum test. So it means that if
Is
you
it
do normality
what? Hello?
with this with cousin rank sum
Okay.
test. Uh-huh. So it
Okay.
means that if it's not normally distributed, you will use this. But if it's normally distributed, use this one sample t-test. Sorry. Then if it's a two sample t-test, the question you also ask yourself is that is it normally distributed? If it's normally distributed, yes. Now, if is it paired sample? Now, when we say paired sample, we are talking about let's use your 2 hours postprandial test, for example. Let's say you have 20 patients, pregnant women. You took their fasting sugar. Then you now take uh, their postprandial test 2 hours later. Now you are trying to check there is difference between their fasting and their 2 hours postprandial. You know, it's from one group of patients, but you have collected two different samples from them. So that's why we
Okay.
say paired sample. So if it's a paired sample, meaning that you have the same number of group collected the same kind of sample from there twice and run the same kind of test twice, then you will be using what we refer to as paired t-test. So is that okay?
Yes.
But if they are not paired, then the next question you ask yourself is that are they equal variance? Then if they are equal variance, then you use what we refer to as unpaired t-test. But if they are not equal variance, then we use what we call weight corrected unpaired t-test. So all those are just languages. By the time we start applying them, we will see their real application. Now, the next thing that you also want to ask yourself is this: if it's not paired, then the next thing that you ask yourself is that are they okay? We already said if they are two samples, if they are normally distributed, you use paired. Then if they are not normally distributed, then we use what we refer to as with Cohort matched pair test. If they are paired, if they are not paired, then we use what we call Mann-Whitney test. So all those are actually, and statistics is actually divided. Statistical test is divided into two. Let me quickly mention that. There's what we call parametric test and non-parametric test. Parametric tests are usually tests that you do when the samples are normally distributed. While non-parametric tests are tests that you do when samples are not normally distributed. So that is that. Then if there are more than two, then you also ask yourself, are they normally are they normally distributed? Yes, if they are normally distributed, you also do the next question is that are they paired? Then if they are paired, then you use what we refer to as repeated measured one way and over. Repeated measured one way and over. But if they are not paired, then you use what we refer to as one way and over, the normal one way and over that we know. Then the next thing that you have to ask yourself is that if they are not normally distributed, then you also ask yourself, are they paired? Then if they are paired, you use what we call Friedman test. All of them, we are going to see them when we start looking at them practically. Then if they are not normally distributed, we use what we call Cosia Willis test. That is a
Yes.
Cosia Willis test. So those are the uh, kind of test that you can actually do for at every given point in time. Please, you will give me a minute. My data is about. I'm trying to actually get another data. It seems so that it will not take us out. And the app is not.
Okay.
It's not going. I don't know how I even forgot. So. I don't know. I'm not able to log into the app to back. So let's continue. It's likely to take us out. So let me continue. So then okay, let's now this is example. This is an example. Okay, let's use this as an example. A researcher, for example, here is a question. For example, let's say a researcher assigned 56 subjects to apply for SPF 85 sunscreen. This is actually a type of sunglass
Okay.
of their face, and then there's another one that is referred to as SPF 50 to the other priority to engage in 5 hours of outdoor activities. So what this simply means is that the study was meant to test two types of sunglasses. The first one is SPF 85, and the next one was SPF 50. So size of the faces were randomly assigned. Subject were bind to either of these strengths. Then the outcome was to check for sun burns.
No.
Now this is the table. Now we have two groups, 85 and 50. Then
Okay.
remember that the total, are you with me?
Yes.
Now we have two groups.
Yes.
We have the 85 group, then we have the 50 group.
50.
These numbers are actually the designation that is given to the sunglasses. Then they were now checked for sunburns. Then we have two outcomes. It's either we have a sunburn or we have no sunburn. Then out of those that remember the subject is actually 56 each. Then out of the one that the sunglasses that is assigned 85, one said that he or she had a sunburn. Then why 85, 55 said they do not have any sunburn. Then for those assigned 50, 8 of them said they have sunburn, while 48 said they did not have sunburn. Now, for this kind of study, remember that there are another thing that I will quickly mention. There are other kind of tests that also will still come there that we are supposed to do. You know that like this now, this is actually a categorical data. It's either you have a sunburn or you do not have a sunburn. Are you getting me? So in this kind of study, you are either going to use your chi-square or you use Fisher exact test. Now, but this particular group do not meet for chi-square. The reason is because at any time you want to do a chi-square test, you need to check the distribution. If any of the buses have anything less than 5, is not qualified. So here is 1. So because of this one, what is qualifying that this test qualify for is the Fisher exact test. But if here was 6, here was 8, and all of that, then it would have been qualified for chi-square. Did you get that explanation?
No, I didn't get this particular one.
Okay. What
About the
I'm saying is,
Fishers and
in
the
essence,
chi-square.
in essence, is usually for this kind of data, there are two tests that you can do: Fisher exact test or chi-square. Now, there are conditions that must be met for you to be able to do chi-square. And the first condition is that the test for chi-square, that each of the boxes must have numbers that is up to 5. Are you with me?
Okay.
So, like here now must be either 5 or more. For here
Okay.
to 5 or more, 5 or more, 5 or more. So if you have 5 or more, 5
Okay.
or more, and 5 or more in all of them, then it's qualified for chi-square.
That's
But if
clear.
it's less than, if any of the group is less,
Mm.
buses is less than 5, then it's not qualified for chi-square. Then you do what we refer to as Fisher exact
This guy,
test.
yes.
So that's the reason why here Fisher exact test was used in this case. So is that clear?
Okay. Yes.
Now here, okay, now no, let's leave this. Let's come here so that I will explain further. Now
I'm
this
sure
is a
is
continue.
she still with us?
Oh, let me check. Yeah, she is. I think she went out and come in.
Okay. Okay.
So um, this is another.
Yes,
Of, yeah, this
my
is a
network going off
okay.
and
No
on.
problem. This is another overview of common statistical tests and how to know the kind of test to do. Here we said that the outcome variable here is continuous. Are you with me? It's
Yes.
continuous. It's continuous. Example is blood pressure, age, pain score, glucose level, cholesterol level, and all of that. All of them are continuous data.
Mm.
Now, the next thing that you need to ask yourself is, are the observation correlated? If they are independent, then you do t-test, ANOVA, linear regression, linear correlation, then linear regression. Now, we already talked about condition to do t-test. If it's a one group,
Yes.
you do one sample t-test. If it's a two group and it's normally distributed, you do two sample independent t-test. But if they are paired, you do pair t-test. So if there are more than two, do repeated measure, one way ANOVA, and the rest. Then the observation is normally distributed. So for you to use any of it, they must be normally distributed.
Yes.
So so the next thing is if they are binary or categorical. For example, breast cancer is either yes or no. So you use, if they are independent, you use what we refer to as chi-square test or relative risks or logistic regression, as the case may be. Now, if they are correlated, they are related, you use a Mark-Newman's test or you use conditional logistic regression. Now, remember the assumption here is that chi-square test assumes sufficient number in each box, so it must be greater or equals to 5, like I explained in the previous, the preceding, what's it called, the preceding um, slide. Now, the next one is that, is it a time to event series? Now, we are talking about time to die, time to fracture, and all of that, or time to heal and all of that. Then we'll be using Kaplan-Meier statistic or cost regression. These are actually more advanced kind of statistics that are used to do what we refer to as survivor analysis, um, to check for survivor analysis for particular. This is usually utilized in a drug and equipment or devices aspect. Now, here is a cost regression assumes proportional hazard between group. That's only when you are looking at a hazard between a particular exposure or use of drug and all of that. Now, the next thing is is we are still talking about these continuous variable. Now then we are not taking the one after the other. Now we are saying here that if it's a t-test will compare mean between two independent tests. That if they are independent, meaning that they are not related to each other. But if they are related to each other, to be comparing mean between two related groups, e.g., the same subject before and after. Did you get that? Before and after. Just like the when I use these 2 hours propangia to make an example. It's the same group you are looking, same individuals you are looking at, but in this case you are trying to check before they eat and after they eat. So that's that. Now these two tests are parametric tests. Now the non-parametric equivalent of this test, if they are not normally distributed, then you'll be using, like I mentioned, with quotient, that is Will Cousin sign rank test. Now, this is actually the non-parametric alternative to your paired t-test. Now, the next one is ANOVA. ANOVA compares means between more than two independent groups. So, in this case, if they are still independent, they are not related to each other, but you are, for example, male and female, they are not related. Boys and girls, like I said, the cholesterol level in the 6 geopolitical zone, they are not related. So in that case, you use ANOVA. But if you are looking at the cholesterol level in Southwest, for example, for the three or the 6 porters, let's say you have 3 group of individuals, then you collected their cholesterol level at first quarter of the year, second quarter of the year, third quarter of the year, fourth quarter of the year. So that is actually a repeated measure. So in this case, you use what we refer to as repeated measure ANOVA, and they must be normally distributed for you to use this. If they are not normally distributed, you use either Mann-Uni's test or you use the Coulson-Willis test. Now, the next one is that Pearson correlation coefficient. This is linear correlation showing linear relationship between two continuous variables. So it therefore means that for you to use this kind of test, that you must be dealing with continuous variable. Now, then if you are looking at the correlated aspect, then you'll be looking at multivariance regression technique to compare changes over time between 2 or more groups. Then the next one is linear regression. This is we have a multivariance regression technique when the outcome is continuous, that is a given slope or adjusted when you adjust the mean as the case may be. The non-parametric equivalent is actually the Spearman rank correlation coefficient. So this is actually the equivalent of non-parametric alternative to the Pearson correlation coefficient. So this is, for example, when we are talking about two. Hello.
Yeah, I can hear you.
Okay. So this is example of two sample t-test. Let's say in 1987, this is an example. 2 researchers reported that men have more mathematical ability than women, as evidenced by 1979 stats, where a sample of 30 random male adolescents had a mean score plus or minus standard deviation of this and this, and 30 random female adolescent score was this and this. We are similar in educational background, socio-economic status, and age. Now, the reason why you need to take all these things into consideration, because these are possible co-founders or factors that could impact on the outcome. Because if they have different educational background, yes, they are likely uh, to impact them. Then if their age too is different, they are going to be impacted. Then in their socio-economic status too is different, they are going to be impacted. So in this study, the educational background was controlled, the socio-economic status were controlled, and the age too was equally controlled. Now, for us to know whether we agree to the author's conclusion, then we'll now come here and do the next thing. Now you need to ask yourself, based on when we started, the questions I said you should always ask is that, is there a difference in start math score between the male and female? Then the next thing is that, what is the outcome variable? Then the outcome variable here is the math start score. Then what type of variable are we looking at? Is continuous, because we are looking at score. Then the next question is that, is it normally distributed? Yes. So if it's not, we know we are looking at two groups now, male and female. The outcome variable is mass start score. Then what type of variable are we talking about? We're talking about continuous variable. Is it normally distributed? Yes. Then the next thing is, yes.
How do we know that is normally distributed from the patient?
We are going to that's the next, that's tomorrow class. But for us to look at this, I still have to mention this. So,
okay.
Yes, we will know how to check for normality when we go there. So yes, they are normally distributed. Are they correlated? No, because they are not related. Males are different from females. So now, are group B compared, and if so, how many? Yes, group are being compared, and there are two. Remember, we said when you are comparing two groups that are normally distributed, you use t-test.
Okay.
Now, in this case, we are using two sample t-test. And we now come here. So this is how it will be arranged. The group 1 is women and they are 30. The sample mean is 416. The standard deviation is 81. Then for the group 2, they are men. They are also 30. They have 436 mean. Then they had a standard deviation of 77. So now you have to define your hypothesis. I know we have two types of hypotheses. We have null and alternate hypothesis. Now, in this case now, the null hypothesis is that male star score minus female star score is equal to 0. While the alternate is that male starts math score minus females math start score is not equal to 0. Now, you now specify your null distribution. So this is the manual method on how you calculate your t-test. You check for the standard deviation, you check for the standard error of the two mean. Then once you got that, then you now come and check. Check the value. So the differences in mean follow a t distribution. So in this case, when you look at it, you can see that it's actually when you minus, it's not equal to 0. So in this case, we are going to reject the known hypothesis and accept the alternate hypothesis. Because when you minus the mean value of the male from the female, it's not equal to 0. And if it was equal to 0, then you accept this known hypothesis. But since they are not equal to 0, then we reject the known hypothesis. So the t distribution is like that's not really so now this is actually when we are talking about distribution. Now, by the time we are going to be looking at normal distribution, then I will explain all this one better. Let's just leave that out. So that, okay, now, yeah, this was where I was supposed to. So once you calculate your value, you can see the value is actually not statistically significant at this stage, but we are going to, because it already said that it's more than 0, then we will reject that distribution. So that's just basically, I think I want to stop here, then I'll take your question. And when we look at the normal distribution, then you'll be able to actually understand it better, because when we do the check how to do the normal distribution, then you understand those plots. Because even though I'm saying things regarding that plot now, it will not make any sense. So you can ask your question at this point. But my data is already hello. Yeah, my data is already almost exhausted. Hello.
Hello.
Yeah, your mic still is very far.
What?
I say your mic seems far. I can't hear you.
Okay, can you hear me now?
Yeah, I can.
Okay.
So you can ask your question.
Okay. My question now is that
Yes.
you really need to throw more light on that first table, the first table that you brought out. I think that is the basis of everything that we are going to do on this.
Yes.
That
Yes.
particular first table is
So
very important there.
what I will do is that I actually I don't want this thing to stop me when we are doing I don't know why the app is not allowing me to get the card. So what I will do, I will start with that explanation tomorrow, because I need to correlate it with uh, the normal distribution class, so that you'll be able to really grab it. Because I think it would be better if I go
Okay.
hand in hand with that with tomorrow's class. So it will be more easy for you to get that way.
Okay.
So don't know if Lauren have any questions. Hello, Flourish.
No question. Can you hear me?
Yeah,
Hello, can you hear me?
we can hear you.
Yes.
Okay, I think it's maybe because I think why we are in a haste is uh maybe your data is about to finish.
It's actually about
Like you
finish.
said,
So
because
whatever question I will take them tomorrow. Hello, hello.
Hello.
Yeah, I said whatever question that you have, I will take them
all
tomorrow.
right.
Then after tomorrow's class, I will send the slide,
I guess
today's slide,
the
yesterday's
text
slide, today's slide, and tomorrow's slide. I will send
textbook
them to
you
the
sent.
what?
Hello.
Yes, yes. I can hear you. What did you say? Hello.
Hello.
What did you say?
Because I've been
I can't hear you.
screenshotting
I can't hear you. What did you say, please? Maybe you drop the question on WhatsApp because I can't really hear. Do you hear me?
Shorting, although
Drop the question on WhatsApp.
hello.
Hello?
I said drop the question on WhatsApp.
Okay. All right.
You said that you should drop the question on WhatsApp since we can't really hear you very well.
All right. I'll drop it.
Okay, okay. Sir, did you hear her?
I didn't hear her. Please, can you recap what she said? If you heard.
No, I've already told her to drop the question on WhatsApp and she agreed to it.
Yes, that's what I'm actually now.
Okay.
I'm sending a voice. So, sir, what I'm
Okay.
saying is that
Hello?
Just drop the question on WhatsApp.
okay. What I'm saying is I've been screenshotting.
Okay.
Your network is really. I think I will stop. I'll stop. Then any question can be asked on WhatsApp.